Bill Nye, the scientist, has been awe-inspiring us with brand-new discoveries and all of their enigmas for decades. Our interest in the final frontier, with all its mysteries, has been piqued by Bill Nye as he reveals the vastness of space to us. That stretches out around us, and Bill Nye now breaks infinitely above us. Silence regarding the most recent images from the telescope in James's book gives us a look into the universe beyond, radically altering the landscape a billion years ago, our comprehension of the universe, and our perspective on life in general. The telescope is finding out about planets, faraway galaxies, and a lot more. It's a groundbreaking piece of science, a breakthrough, and an excellent replacement for the Hubble Space Telescope. What exactly is unique about the images from the JWST that defied our theories and expectations? What is it that Bill Nye has to say about them? This telescope was created as a result of years of NASA scientists and engineers' work and became operational on Christmas Day 2021. The various telescope steps deployment went off without a hitch over the next few months. By June 2022's end, researchers began uncovering thousands of young galaxies that are older and farther away than ever before. Some of these 150 galaxies might have formed 1 million years prior to the oldest object observed by Hubble. In addition to discovery, the telescope is capable of capturing sufficient light from objects in space, such as exoplanets and stars, to demonstrate their composition and paths taken through space. According to Bill Nye, these data are already starting to show, in great detail, the composition of the atmosphere of planets far away from Earth in light years, allowing recommendations to be made regarding their capacity to support life as we know it. The Hubble Space Telescope, one of the most well-known spots, has been the foundation of the creation in the Eagle Nebula. The telescope mostly looks for visible light, whereas the images from the JWST were snatched up in the form of an infrared image. These stars appear as dusty clumps of gas that are each much bigger than our solar system, represented by tiny red dots in contrast to the background pillars. These are the process's stars of formation. The stars that can be seen in the photograph aren't yet fully formed. However, as hydrogen, in accordance with Bill Nye, attracts more material to the center of the star, it gets denser until it suddenly reaches a density that causes the burning of hydrogen to start, causing a significant rise to approximately 2 million degrees Celsius. The various colors in the image depict wavelengths in the infrared which are largely unseen by us. Only the visible portion of the image is shown in blue. The hues also make the red more intense since the radiation in the image is produced by protostars at a wavelength that is 6 times longer than the human eye can see, as described by Bill Nye. In addition to demonstrating the JWST's infrared capabilities, the telescope has revealed the formation of the first exoplanets. Stars like our Sun were discovered in the 1990s, and today over 3,000 planets have been confirmed circling distant stars, but only a dozen of them have been specifically depicted. The majority of exoplanets are so far away that they can't be seen until the light from their host star is dimmed. A clear photograph of an exoplanet was taken in September of last year, identified and given the name CHIP 65426b in 2017. Scientists use chronographs on telescopes that block out light from the central star and a series of filters for cameras and telescopes, along with additional equipment for monitoring it. The planet has several characteristics that, in addition to being easier to see, demonstrate outstanding sensitivity to the infrared. The planet is very far from its host star, at a 100-fold greater distance than the distance between Earth and the Sun. It is a massive gas giant that spans nearly 12 times Jupiter's size. Despite this, the ghost galaxy is hard to see in the sky, but can be captured in its brightness, particularly when taken with an infrared camera. The galaxy's spiral and its constellation of stars that start at the center have a radial shape, also known as the optical view of the object, M74. On the other hand, A recent image from the JWST shows what appear to be structures like dust-producing, heat-producing fibers and gas coming from a bright central area, depicted in vivid blue. This new image will shine light on the star-forming regions dispersed throughout the galaxy's photos taken with infrared light, showing spiral arms. Images from the space telescopes Webb and Hubble have been put together to make a stunning composite image with parts highlighted of the infrared and optical views of the galaxy. The resulting composite image was created by researchers at a space agency in Europe as part of the FANGS project, an international endeavor that makes use of Webb, Hubble, and a few ground-based telescopes observing 19 nearby galaxies in the infrared. With sharp Webb observations at longer wavelengths, astronomers will have the ability to decipher areas of galaxies where stars are formed and accurately count the populations and their ages of clusters of stars and the characteristics of very fine dust wandering through space between stars. In a photograph of the distant Wolf-Rayet star, WR140, captured in July of last year, a recognizable pattern of diffraction, a visible imaging artifact, was observed. Nevertheless, this star is surrounded by a similarly implausible pattern of wavy rings that are concentrated and slightly square in shape, in contrast to the pattern of diffraction, which are known properties of massive stars like Wolf-Rayet stars in the late stages of their lives. WR140's interactions with hydrogen and the small star that is its companion give rise to unusual forms for the rings, which is what the JWST is made to see. The universe's farthest galaxies in the middle of December last year were discovered. Researchers stated that they had found 4 of the earliest known galaxies that the JWST has seen for the first time, 13.4 billion years old, when the universe was only approximately 350 million years old, about 2% of its current age. These 4 galaxies were believed to be extremely ancient, similar to the countless additional galaxies the researchers discovered via the JWST. They determined the galaxies' ages as part of the strategic survey of the JWST, making use of data from the near-infrared spectrograph for quick measurements of the galaxy's isolation. This enlargement of light waves brought on by the growth of the universe is measured by the red shift. The largest red shift in galaxies ever weighed was 13.2. These galaxies are more than we could have anticipated to find before the JWST. The JWST can utilize this to locate distant galaxies, followed by spectroscopy to check if they really are that far away. In the interim, the JWST has analyzed a star-circling planet in one of the constellations in Virgo, one of the most comprehensive examinations of an exoplanet, named WASP-39b, situated 700 light-years away from Earth, approximately 8 times closer than Mercury is to the Sun. A gas giant the size of Saturn boils as it orbits its star. The atmosphere of the planet is dominated by a dense cloud that contains silicates, including sulfur and sulfur dioxide. Researchers were able to locate carbon dioxide in the atmosphere using 2 of the JWST's spectrographs. Now tell me what you see. Please share your thoughts in the comment section. Please subscribe and like the video. Moreover, I hope to see you in the following video. The James Webb Space Telescope, JWST, is regarded as the most prominent global astronomical instrument. The primary objective of research is to examine the mysteries that surround both our own solar system and other solar systems, as well as exoplanets orbiting distant stars as a means of studying the intricate structures that shape our place in the universe. In an innovative effort, scientists recently targeted a star with the JWST, 120 light-years away from our solar system. As a result, the powerful James Webb Space Telescope found convincing evidence implying that there are carbon-based molecules in a city's atmosphere. This conceivable planet with oceans, far beyond Earth, has astonished the astronomers' community. But how remarkable is this? The possibility of this revelation provides a fascinating look at a planet that stands out significantly from others discovered in the solar system, while simultaneously putting forth provocative questions regarding the probability of habitable worlds elsewhere in space. Space is an endless expanse that joins us as we learn more about this discovery of an exoplanet. Deeply explore and display the enticing information it contains. If you wish to remain informed about the most recent developments regarding the universe and beyond, make sure to sign up for our channel, like the video for others, and turn on the stay notification bell. NASA's current James Webb Space Telescope has made significant strides in gathering new information regarding the exoplanet. K2-18b, a planet 8.6 times larger than Earth. This is what makes this finding so remarkable and exciting. The discovery process includes the finding of carbon-based compounds, like methane and carbon dioxide, in its atmosphere. The observation by the telescope backs up earlier studies indicating that K2-18b may have favorable conditions for life. It seems to have a surface and an atmosphere rich in hydrogen covered in oceans. The initial analysis of this exoplanet's atmosphere characteristics contained in the habitable zone was created by NASA's Hubble Space Telescope, significantly improving our understanding of the system. It must be emphasized that K2-18b can be found 120 light-years away from Earth in the Leo constellation. It orbits K2-18, a cool dwarf star in the zone that can support life. Exoplanets like K2-18b, which range in size from Earth to Neptune, represent a rare group in our solar system because there aren't similar planets in the vicinity. The possibility that K2-18b has a significant amount of hydrogen and a carbon-dominated atmosphere fascinates astronomers. Numerous specialists hold the belief that it could provide ideal conditions for looking for signs of life. The presence of methane and carbon dioxide, combined with the absence of ammonia, bolsters the hypothesis, suggesting that this exoplanet contains a sea beneath it. Early research on an atmosphere rich in hydrogen has additionally proposed that dimethyl sulfide, a chemical made by marine organisms like plankton on Earth, could be present in K2-18b's atmosphere. However, this is supported by evidence that encroaches on K2-18b remains uncertain and needs additional evidence and verification, using the JWST telescope for observations. This array ought to assist in determining whether dimethyl sulfide is, in fact, present in significant numbers in K2-18b's atmosphere, as a researcher from Cambridge University made the distinction. That being said, K2-18b within the habitable zone includes carbon compounds, which does not necessarily indicate that life can survive there. The planet's radius, which is 2.6 times larger than Earth's, suggests a thick layer may surround its core, an ice mantle with high pressure, similar to Neptune. Additionally, it has a thinner surface and an atmosphere rich in hydrogen, surrounded by oceans. While liquid oceans of water are expected on this exoplanet, it's possible that these oceans are too rigid or insufficient to support life. However, researchers have been successful in obtaining the most comprehensive spectrum of a currently habitable sub-Neptune planet, allowing them to recognize the molecules present in its atmosphere. The Cardiff University team provided an explanation that this obstacle was conquered by examining light coming from K2-18b's host star as it moved through the planet's atmosphere. K2-18b is classified as a transiting exoplanet, which means its brightness decreases when it moves in front of its host star. NASA's K2 mission discovered this exoplanet during these transits, through which some sunlight filters through the exoplanet's atmosphere before gaining access to space telescopes like the JWST. As the sun moves through the atmosphere left behind by an exoplanet, signatures can be used by astronomers to determine which gases are present. The research team plans to carry out additional studies using the mid-infrared spectrometer of the JWST to confirm their findings and gather additional data on K2-18b's climate. The group's ultimate objective is to look for evidence of life on habitable exoplanets, a breakthrough that could change everything and further our comprehension of the universe. Other amazing discoveries have been made by the JWST. Astronomers, using telescopes, have uncovered intricate organic molecules that look like smoke or smog in a distant galaxy. This discovery identifies the earliest evidence of such molecules in the universe, and I find this to be both encouraging and troubling. These discoveries were made in the farthest parts of the universe, changing the shape of our cosmology's very foundations. The significance of this finding lies in the fact that these molecules, referred to as aromatic hydrocarbons, were discovered in a galaxy that came into existence when the universe was less than 10% of its current age. These carbon-based molecules can be found in the world's coal and petroleum deposits, as well as in atmospheric pollution like smog, and are a vast and intricate collection of dozens, hundreds, or even thousands of atoms. What makes this find so remarkable is that such intricate and massive molecules formed so quickly following the Big Bang, defying our preconceived notions and current models of the cosmos. To put this specifically, the light detected from this early galaxy began its journey less than 1.5 billion years after the Big Bang, whereas the universe is roughly 13.8 billion years old. We are witnessing a portion of the cosmological earliest stages of development. The most remarkable aspect is that the detection of these intricate organic molecules was made possible with the help of the Webb telescope, which keeps making it possible for us to make similar observations regarding nearly 1 billion additional years. If we were able to look back even further, could we find even more of these molecules nearer the Big Bang? This alone raises significant concerns about our understanding of science and cosmology up until this point. Previous attempts to identify intricate organic molecules in old galaxies could only confirm their presence, but with the greater resolution of the Webb telescope, the fine specifics about where these molecules are located, in addition to the uneven spread of these molecules throughout the earliest galaxy, can now be examined. What remains a mystery about SP4 1847 is that this galaxy was already larger than ours, with stars that had produced the same amount of carbon and oxygen as the Milky Way, despite being only 1/10 as old as our galaxy. As humanity expands its horizons with the knowledge to face the unknown, we are humbled by the insight, magnitude, and complexity of the universe. With each new scientific development, we progress towards solving the mysteries in the heavens.